These are the notes for magnetism. Here are the words to know: magnetism, lodestone, magnetic pole, magnetic field lines, electron, magnetic domain, ferromagnetic material, permanent magnet, compass, magnetosphere, electric current, electric circuit, electromagnet. Here are the key questions. What is magnetism? How do magnetic poles interact? What is the shape of magnetic lines of force? What makes something magnetic? How is Earth like a magnet? How does magnetism produce electricity? What do you think all of these have in common? Well, believe it or not, ceiling fans, garage door openers, computer speakers, all of these things involve magnets. And we really need to understand what magnetism is in order to know how these things work and how to make new technologies. Magnetism is the attraction or repulsion of one magnet to another. And we can make these poles interact by putting them together, and each of these ends is the pole. And this is where most of the area effect is, on the ends. It's where it's the strongest. And we have these opposite poles called the North Pole and the South Pole, and every magnet has one of each. And if they are alike, they repel, and if they're unlike or opposite, they attract. Look at these magnets here. This is a horseshoe magnet. We have a north and a south. And on these bar magnets, we also have a north and a south. All magnets have both a north and a south pole, and it doesn't matter if we chop them in half or not, there's still a north and a south pole. Now, all magnets also have a magnetic line of force, and they are all around a magnet and they extend out into space around it, and we can't see them. And these are magnetic field lines that extend out. This is what the magnetic field lines look like. These are complete loops that never cross. And we can use compasses and to use these iron filings as well, and we can see the magnetic field lines. And if we bring two magnets together, we can see how these lines of force change. If they're opposite, they'll connect, and if they're the same, you can see the lines repelling each other. What makes something magnetic? Well, we have to get down to the structure of the atom to really determine what makes it magnetic or not. The spinning and orbiting motion of the electrons are what makes something a magnet. And remember, all atoms are made up of protons, neutrons, and electrons, and depending on how many protons and electrons something has, properties can change. So not everything is going to be magnetic because they have different numbers of electrons. So a magnetic domain is a cluster of billions of atoms that all have magnetic fields, and these are either lined up in the same way if they're magnetic or not. So in a magnetized material, all or most of these domains are arranged in the same direction. Which one of these two do you think is magnetized? Well, this one's not magnetic. The domains, these areas with the arrow, they're going in different directions. If most or all of them are in the same direction, it's magnetized. All the electrons are spinning the same way in this one. So ferromagnetic materials such as iron, nickel, and cobalt can have their domains lined up easily because of the nature of their electrons. We can make something magnetic if it's ferromagnetic by trying to line up all those domains, such as taking a magnet and running it up the same direction on a nail. That can cause that nail to become magnetic because you're lining up all the domains in the same direction. You're making them go from looking like this to looking like this. Earth is like a magnet. And we can see Earth's magnetic field by using a compass. It lines up with the magnetic field and it shows us which way is north. Earth has that magnetic field and it extends out into space, just like the field lines around a bar magnet extend into space as well. And Earth's magnetic field blocks the solar winds. Without that magnetic field, we wouldn't last long because those charged particles would strip away our atmosphere. So it's a good thing that we have the magnetosphere. This is a depiction of our magnetosphere. You can see how it extends out and looks just like a bar magnet. The ferromagnetic core of the Earth is what gives us a nice magnetic field. Magnetism can produce electricity, and electricity can produce magnetism. When we have electrons flowing through a wire, we have a current, which is measured in units of amps. And that current will produce a magnetic field. And that direction of the current will determine the direction of the magnetic field. Using electricity, we can make an electromagnet, which is great because we can adjust the strength of that magnet and we can turn it off and on. We can adjust it by changing the current in the wire, the number of loops, space between the loops, and the type of core we use to make that electromagnet. And that's it. That's the end of the Magnetism Notes. Go back and review if you need to.